It's fun to watch stuff, bruh. Stuff, bruh. Blah 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 blah. This is a non-appropriated something, whatever that word means. So, and it's not stopera. It's not.
Go. Today we're going to be explaining what happened in this experiment that's been done in scientific format. The steps of scientific format are: first one is observation, second one is question, third is hypothesis, fourth is doing the experiment, and fifth is the conclusion. In this experiment, we've skipped the observation and went right to the question. The experiment is proving the law of conservation of mass. So first, the question is, will the mass of a bottle and balloon change when you combine water and baking soda? And our hypothesis is the mass of the bottle and balloon will not change when you combine baking soda and water because of law of conservation of mass. In the experiment that they're doing, the experiment tools that are needed are baking soda, an empty water bottle, water, a balloon, and a regular size spoon. But what experiment we're gonna be doing is, so the bottle is gonna be filled with water, and then the baking soda is gonna be put, like 1 spoonful, I guess, is gonna be put in the balloon, and we're gonna attach the balloon to the water bottle without the baking soda and water touching. And once we have it attached, we're going to drop the baking soda into the water and see what happens if it blows up the balloon, and if the mass changes or if it doesn't.
Guys, I think hoodies are not just
He said I'm a giraffe. All right, and we're back.
That just makes it that much worse.
So we have a special guest star, Gwen, and she brought me a little project that she's doing for school. Explain your project, Gwen.
I prefer you to do it.
Oh, you want me to do it?
Yeah.
Very unprofessional, but you know what? We're not professionals here. We're all in middle school. Okay, so I guess Gwen's learning about the law of conservation of mass. And you know how the first step is always asking a question? My question is, will the mass of the bottle and balloon change when you combine water and baking soda? Cue the music.
They showed their data in a table, and they did 4 tests. The first test, the amount of mass of baking soda is 12 grams. The mass of the water bottle is 125 grams. The mass of the water bottle and baking soda is 103 grams. And the question is, did the mass stay the same and why? The answer is no. It did not stay the same because the chemicals were not contained. Test 2, the amount of mass of baking soda is 12 grams. The mass of water bottle is... Okay, so the experimental error was because in test 1 and test 4, the mass didn't stay the same because the chemicals weren't contained in the balloon. And in test 2 and test 3, the mass did stay the same because the chemicals were contained in the balloon. So the cause was because that they were mixed together, and the effect was it should have stayed the same or it shouldn't have, but half of them did stay the same and half of them didn't due to experimental error.
Test 1, we have 12 grams of baking soda. The mass of the water bottle was 125 grams. The mass of the water bottle and baking soda was 137 grams. Did the mass stay the same? No, because it didn't have the chemical contained in the balloon. Test 2 was also 12 grams of mass of baking soda. The mass of water bottles stayed the same. The mass of the water bottle and baking soda stayed the same. But the mass stayed the same. Yes, the mass did stay the same. Because the chemicals are contained. Test 3. The mass of baking soda stayed the same. The mass of the water stayed the same. And the mass of the water and baking soda stayed the same. The mass did stay the same because the chemicals are contained. Test 4. The mass of the baking soda stayed the same. The mass of the water stayed the same. The mass of the bottle and baking soda stayed the same. Did the mass stay the same? No. Why? Because it didn't have the chemicals contained.
Okay, so back to the chart. The cause was the baking soda and the water bottle. The water bottle and the baking soda's mass were all the same. All the mass of the baking soda and all the mass of the water bottle stayed the same, but you got different results. Correct? So the faulty interpretation was because of experimental error. So test 1 and test 4 were different from test 2 and test 3. That was because in test 1 and test 4, the mass because the mass in test 1 Today we are doing an experiment with the scientific method formation, and we're proving that what law of conservation of mass does not change the mass.
And we're back. I have the student Gwen talking about the hypothesis. You want to do it yet? Well, you know, this episode's still about the scientific method if you're just viewing it now. I have my paid friends here. Daniel, come on. I have my paid guest star. She wanted to be on the show. She emailed me. We usually email this test. Well, now the hypothesis is the mass of the bottle and balloon will not change when you combine baking soda and soda water because of the law of conservation of mass. Now, Gwen, that's a very strong point. Why do you say this?
I got you. Because it is part of science. That's what the textbook says, bro. Broski.
Excellent observation. We are getting so deep into this that I think we need to go a couple steps deeper into the scientific method. So deep. Cue the music. And this is what she thinks will happen. The mass of the bottle and balloon will not change when you combine baking soda and water because of the law of conservation of mass. Cue the music. Hey, and welcome to Stopra. There's supposed to be lights right there. Okay, you can do it all. So on this episode, you know, we're talking about the scientific method. This is my teacher. She's walking over. Come on.
Hey, Miss Sanders. Woohoo!
Tell us about the scientific
But you
method.
just walked through our video, like.
And this is what she thinks will happen. The mass of the bottle and balloon will not change when you combine baking soda and water because of the law of conservation of mass. Cue the music.